heard in the news that the share price of a particular product goes up this week and drops suddenly in the next week. This is due to the supply and demand of that product. In the same way, some functions also increases and decreases with respect to the intervals and point. Let's have a look at how these occurs. To understand the concept of increasing and decreasing function, let us compare two linear functions which are in slope-intercept form y equal to mx plus v, y equal to mx plus c. The function f of x equal to x plus 3 and the diagram to represent this function is here. Here the slope m is positive. We notice that for positive slope y increases with increase in x. So it is an increasing function. Now consider the function f of x is equal to minus x plus 3. In this case, the slope is found as negative. For negative slope, y decreases with increase in x. So it is a decreasing function. Now we can discuss the analytical definition of a function which is increasing or decreasing on an interval. Increasing function. Let f be a function defined on an interval I. Then for any two numbers x1 and x2 in the interval I, that is, f is said to be increasing on I if f of x1 is less than or equal to f of x2 whenever x1 is less than x2. And the graph is here. Next, we will see what is a strictly increasing function. The function is said to be strictly increasing on I if f of x1 is less than f of x2 whenever x1 less than x2. This function is called strictly increasing function. Strictly increasing function means the function will always increase for a domain. Next, we will see decreasing function. Decreasing function means the function f of x is said to be decreasing on I if f of x1 is greater than or equal to f of x2 whenever x1 is less than x2. Now, what will be the case if it is strictly decreasing? Now, what will be the case if it is strictly decreasing? The function f of s is said to be strictly decreasing on I if f of x1 is greater than f of x2 whenever x1 is less than x2. This is called strictly decreasing function. Strictly decreasing function means the function will always decrease for the domain. And the another category is nothing but constant function. Here the function is said to be a constant on I if f of x is equal to c, where x element of I. Here you can see a constant function. In this figure, it is neither increasing nor decreasing. Hence, it is a constant function. Now we can discuss the definition of a function which is increasing or decreasing at a point. Let f be the function defined in the domain and x0 is the point in the domain. Then f of x is said to be increasing, decreasing at x0 if there exists an open interval I containing x0 such that f is increasing or decreasing respectively in I. This is an example. As you can see, a point is marked which is called the inflection point. What is an inflection point? It is a point on the curve where the curvature changes. Now, let's discuss about the first derivative test for increasing and decreasing function. Before that, let us recall about mean value theorem. If a function f of x is continuous on a closed interval ab and differentiable on an open interval ab, then at least one number, that is c element of ab, exists such that f dash of c is equal to f of b minus f of a, the whole divided by b minus a. Now let's see the theorem. Let f be a continuous on the closed interval ab and differentiable on the open interval a comma b, then The function is increasing in the closed interval AB if f dash of x is greater than 0 for each element of AB. Then f is decreasing in the closed interval AB if f dash of x is less than 0 for each x element of AB. The third is f is a constant function in the interval AB if f dash of x is equal to 0 for each x element of AB. Now let us see proof of the theorem. Let x1 and x2 element of the open interval AB such that x1 is less than x2. Then by mean value theorem there exists a point C between x1 and x2 such that f of x2 minus f of x1 is equal to f dash of c into x2 minus x1. So here f of x2 minus f of x1 is greater than 0 because it is given f dash of c is greater than 0, which implies f of x2 is greater than f of x1. For x1 less than x2, f of x1 is less than f of s2 for all x1 and x2. Hence, it is an increasing function. In a similar way, decreasing and constant functions are verified. Let us now discuss the various steps to calculate the intervals of a given function. Step 1. First, differentiate the given function to get f dash of x. Then equate f dash of x is equal to 0 to get the value of x. Then, with respect to x, divide the open interval into disjoint intervals. Next step, take a value from each interval and substitute in f dash of x and check for the sign. Now, if f dash of x is greater than 0, we can say it is an increasing function. While if the f dash of x is less than 0, we can say it is a decreasing function. And the last step, write the intervals of increase or decrease. Alright. Now, using this, let us solve one example to get a better understanding. Find the interval in which the function f is given by f of x is equal to x square minus 4x plus 6 is increasing and decreasing. Here it is given f x is equal to x square minus 4x plus 6. Now first find f dash of x. F dash of x is equal to 2x minus 4. Now equate it to 0. We get 2x minus 4 is equal to 0. From that we get x is equal to 2. Then with respect to the x, divide the open interval into two disjoint intervals. That is from minus infinity to 2 and other is from 2 to infinity. Now substitute the values in the f dash of x. Now substitute the intervals in f dash of x. That is, for minus infinity to 2, f dash of x is equal to 2x minus 4, which is always less than 0. So we can say the function is a decreasing function in this particular interval. Now, when the interval is from 2 to infinity, we can find f dash of x is equal to 2x minus 4 is always greater than 0. So, this function is an increasing function in the interval 2 to infinity. With that, we have learned to know how a function is increasing or decreasing. In coming section, we will be dealing with another important application of derivatives. Now, let us summarize what we have learned.
Manorama Horizon. Learning made simple.